In a modern operating room, seconds are a currency. A surgical team's precision dictates the immediate health of the patient on the table and the compounding efficiency of the entire hospital's daily schedule. To manage this complex environment, hospitals rely on electronic health records. OpTime acts as the foundational layer, serving as the master record for clinical charting, billing codes, and the surgical schedule. But while this system records what is scheduled to happen, its data is essentially static. We can see the divide here. On the left, a structured grid of EHR data. On the right, the physical reality of workflows, where real-world friction lives. Dashboards capture macroscopic delays from the left, but miss the minute-by-minute frontline chaos on the right. Operating without this granular telemetry creates systemic blind spots in tracking patient readiness and managing room turnovers. Structural clinical systems alone are insufficient. A static grid cannot map the real-time physical realities of a surgical day. To achieve true perioperative efficiency, hospitals must build a multi-layered data pipeline capable of capturing those invisible workflow barriers. The first step integrates the OpTime database at the base with the dynamic Ready4OR tracker. Next, we add a localized mechanism capturing real-time friction reports directly from frontline staff. Finally, an AI filter ingests and synthesizes these overlapping streams. This configuration transforms a hospital's approach from passively reporting bottlenecks at the end of the month to proactively capturing undocumented near misses exactly as they happen. This pipeline provides the high-signal analytics clinicians need to justify changes to their surgical environments. We are going to trace the exact flow of data through this pipeline to see how modern informatics translates operational noise into clinician-led quality improvement. The foundation begins with a direct digital handshake between OpTime and Ready4OR. OpTime establishes the daily master schedule, passing structural data regarding patients, procedures, and staff assignments downward into the operational layer. Ready4OR then acts as a specialized telemetry layer. It instantly tracks the prerequisites for those scheduled cases, pre-op clearances, incoming lab results, and the preparation of sterile equipment. By actively monitoring these variables, the system catches missing requirements and coordinates staff to prevent case start delays before the patient enters the operating room. Once the procedure begins, the flow of information reverses. Ready4OR begins continuously feeding real-time status updates from the operating room back into the central electronic health record. The system tracks specific intraoperative metrics, such as precise cut times, the completion of surgical milestones, and projected closure times. This precision synchronicity provides charge nurses and anesthesiologists with an accurate, macroscopic view of the entire surgical board at any given second. This baseline integration creates a unified view of case progress. It effectively solves macro-level delays, yet it leaves the micro-frictions of the surgical day largely untouched. To find those micro-frictions, we shift our analytical focus away from standard wheels-in to wheels-out metrics and look at the outer blocks of the surgical timeline. These outer blocks represent the second stage of surgery, the highly volatile periods dedicated to patient preparation and the post-anesthesia recovery transitions. The second stage is where systemic hospital barriers routinely threaten to derail the schedules that OpTime generated. This environment frequently produces the near miss. This occurs when a severe delay is narrowly averted, often requiring an invisible force, the intense, unsustainable physical effort of the clinical staff, to push the schedule back on track. Consider a specialized surgical instrument missing from a tray. The circulating nurse might locate a replacement just seconds before the surgeon needs it, protecting the official surgical start time. Because the case technically started on time, traditional EHR systems fail to document the missing instrument or the intense staff friction required to solve the problem. Without tracking these hidden notes, operations leadership will perceive a successful surgical day, while the frontline staff experience a systemic breakdown. Relying strictly on standard tracking penalizes failure when delays occur, but ignores the workflow barriers that cause cascading stress and clinical burnout. The challenge is to mathematically capture a systemic barrier, even if it never resulted in an official delay code. This requires a qualitative dataset driven from the ground up by the clinical staff themselves. Hospitals can implement a frontline input mechanism, like this conceptual mobile dashboard, designed for the fast-paced surgical environment. A single-tap interface allows staff to immediately document flow problems, like missing sterile trays or unavailable transport staff, exactly as they occur. These quick qualitative inputs generate a massive, localized data stream from across the hospital. This raw qualitative dataset is then merged with the quantitative timestamps provided by the EMR and Ready4OR integration. The result is a sudden, overwhelming volume of operational noise, a dataset too dense for any human analyst to parse manually. Gathering frontline telemetry is only useful if the data can be filtered and synthesized for leadership. An AI processing filter translates that raw volume into clinical meaning by directing this chaotic pool into a synthesis model. The AI evaluates frontline text inputs against Ready4OR's second-by-second timestamps. It searches for hidden correlations, identifying exact patterns where reported friction coincides with specific operational states. Finally, the AI strips away noise, generating prioritized action items categorized by root cause. The AI does not make operational decisions. Instead, it isolates the variables causing the systemic friction. These specific insights allow leadership to replace reactive guessing with targeted, validated interventions based on clear statistical signals. The AI filter serves as the bridge, taking the qualitative frustration of human clinicians and converting it into structured, actionable operational data. This end-to-end architectural diagram shows the data pipeline in its final form. The direct integration of EMR and Ready4OR provides a necessary structural and operational scaffolding for the hospital. Integrating AI-filtered frontline inputs transforms this data into a quality improvement engine that reacts to the actual friction reported on the ground. These clean data streams are routed directly back to frontline clinical leadership, not just to executive boardrooms. Providing high-signal analytics directly to clinical leads gives them the objective evidence required to design and scale localized improvement projects. When armed with accurate system-wide data, frontline staff are better positioned to design lasting operational solutions for their specific departments. Those localized workflow adjustments then feed directly back into the master optime layer, formally closing the operational loop. By connecting structural EHR systems with frontline telemetry, hospitals create a data-driven feedback loop that aligns administrative strategy with the physical realities of the operating room.